Okay, good morning, students. So let me share my screen first. Okay, so I hope my screen is visible to everyone. Let me check. Yes, okay. Okay. So in the previous class, we started off with the medium access control sublayer, right, or the MAC sublayer, right? And we have studied the multiple access protocols. Now, why do we need multiple access protocols? Because whenever there are more than one number of stations inside a network, so obviously what we need to do is that these stations will actually need to share the medium or share the channel when sending the data, right? And obviously we have seen that whenever they are sharing the channel, what can happen? Collisions can happen, data can get lost, right? Data may not get delivered, acknowledgement may not get delivered, and so on, right? And for these we have studied the error corrections, error detection methods. We have studied the flow control methods, right? Also we have studied that how we can allow all the networks or all the stations to allow or to access a channel at the same time, right? And for that we have seen the random access protocols. We have seen Aloha, we have seen pure Aloha, slotted Aloha, right? We have seen CSMA, that is carrier sense multiple access. We have seen carrier sense multiple access with collision detection. We have seen carrier sense multiple access with collision avoidance, right? Also we have seen the control access protocols. So we have seen reservation, how reservation frame is there, and all the stations who need to send the data will actually send the data to the reservation frame, and this reservation frame will actually go around the network and will deliver the frames likewise, right? Similarly we have seen polling. We have seen two packets here. One is select packet and one is poll packet, right? When do we use the select packet? So whenever the primary station needs to send data to the secondary station, so then we have the select packet, right? And similarly when the primary station needs to receive data from the secondary stations, so then we have the poll packet. Okay, so again we have seen what is polling. Then lastly we have seen the token passing. And what is a token? We have understood that it's a special packet or a special frame which is actually the concept is what the station who has the token will be actually able to send the data. And after it has completed sending the data, so what it will do, it will just pass its token to some other station who has data to send. So we have seen all these things. And today what we will do is we will see the channelization protocols. And this will be the end of your syllabus for my part. So I will be completing my syllabus today. Wong Muhammad has already, I guess, completed her syllabus. Saurabh sir is left with the TCP and the UDP. So again that will take another 2 classes. Okay, so again so this will be the end of your syllabus. And after the midsems, if some classes are there, then we can give some assignments. And what assignments will we give? We will have some suggestions, right? So that we will give it to you before the main exams. Okay, and from those suggestions we will give some assignments and you will be able to solve the assignments. And after the assignments, finally before your exams we will give you some suggestions, and obviously you can study from those. Okay. Now for today's class we will see the channelization protocols. Now what are these? These are actually divided into 3 parts: the FDMA, the TDMA, and the CDMA. CDMA is a new topic, so we will study that. And for the FDMA and the TDMA part, these are very much similar to the multiplexing that we have studied in the physical layer, right? So if you remember, in the physical layer we have studied multiplexing. Now what was the concept of multiplexing? That whenever we are sending a signal, the signal, suppose 3 stations are sending a signal at the same time. So what can be done is these signals, all the 3 signals can be multiplexed together, and they can be passed through a channel. And whenever it goes to the receiver side, there is a demultiplexer. And what does the demultiplexer do? It will actually just demultiplex the single signal into 3 signals, and it will deliver it to the 3 receivers, right? Similarly in the case of TDM, that is time division multiplexing, we have seen that again normally we say that a channel is divided into what? Time slots. Okay, Now if you remember, we have seen that there's a multiplexer that will actually take all the signals from the sender, right? It will give it to the various time slots that we have in the channel, and these time slots, they will travel together. Obviously different time slots will travel together and will go to the receiver side. And at the receiver side, what happens, that the demultiplexer that is there at the receiver side will actually take out this data from the various time slots, and they will give it to the receiver side. Okay, so the same logic applies to the FDMA as well as the TDMA. So since we are talking about multiple access, so obviously using FDMA we can have multiple stations, send data together in a single channel, right? Similarly, in the case of TDMA, we can also have various stations sending data together in a inside a single physical channel. Okay, and lastly we have the CDMA. CDMA is a bit different concept, and we will study, or we will see what is a code, what is division in that case, and how different stations can use the CDMA protocol to transmit data in the same physical channel. Okay, so again let us start with the FDMA first. So what is FDMA? As I told you earlier, if you remember, in FDMA the available bandwidth of a channel, right, is divided into what? Bands, right? And obviously we have seen in the previous sessions also, whenever we studied the FDM, that whenever we have a physical channel, and whenever we say that the various frequencies of this physical channel are divided, are separate, right? And obviously these channels or the sub channels will be separated using what? A guard band, right? So why do we need guard bands? If you remember that if there was no concept of guard bands, then what would have happened? The data from the first sub channel and for example the data from the second sub channel may have a tendency to intercept each other, right? And that will be a problem. So again we need some separation between the sub channels. Okay, and this separation is nothing but they are actually frequency ranges, and these frequency ranges are nothing but they are actually called as what? Guard bands, right? Now obviously we have seen an example previously also. So if we consider the FM radio stations, so obviously whenever all the radio stations that we have in Kolkata, for example, they're trying to send data at the same time, right? And obviously the channel that we are talking about is nothing but it starts from 88.7 or 88 till 107, I guess. Okay, so if that's the channel, then obviously we will give separate channels for separate stations, right? Or separate frequencies for separate stations. Okay, so if for example Red FM uses a separate frequency, then Radio Mirchi will again use a separate frequency, and so on, right? And obviously you will not see that if 91.2 is for example one FM station, you will not see that we have given 91.3 to another station. Why? Because obviously we need to separate one station from the another, and this separation of frequency is nothing but the guard bands there that we are talking about. Okay, so again, suppose these are the 4 channels or 4 radio stations that are actually sending the data, and that is denoted by 1, 2, 3 and 4, right? So you can see that if we have a channel, or if we have the common channel that is denoted in between, and this has for example 4 sub frequencies, right? So we can see that the first sub frequency is actually given to the first channel. Okay, the second sub frequency is actually given to the second channel, the third sub frequency is again given to the third channel, and the fourth sub frequency is actually given to the fourth channel. Okay, now again you can see that the station 1 is sending data, right? Station 2 is sending data, station 3 is silent in this case, and station 4 again is sending data, right? And again you can see that all these sub frequencies that are denoted in the common channel are actually separated, right? And the separation frequencies are nothing but the guard bands. Okay, so using this protocol we can allow more than one stations to actually what? Share a common channel using the frequency division multiple access. Okay, so this is one way of doing the things. The second way is that we talked about is time division multiple access. So again you can see in the pointer that is given in the PPT. So in the TDMA what happens is the bandwidth is just one channel that is time shared between different stations. Okay, so again if you see at the middle, if you see the common channel, right, you can see that there are 4 time slots, right, and they are marked in different colors. Okay, And again we can see that again if there are four stations that need to send data using this protocol, so what will happen is, so for the station 1 we have denoted the first time slot, that is the blue one. Okay, again we can see that for the second station we have denoted the second time slot, that is the yellow one. Okay, for the third station again we are denoting what, the third time slot, the green one. And lastly for the fourth channel we are denoting what, the fourth time slot, that is the pink one. Okay, so which means if station 1 needs to send data, it will only be able to send data in the first time slot. Okay, and again after sending data in the first time slot, it will have to wait for the second time slot, the third time slot, the fourth time slot, and after the fourth time slot expires, right, which means for the fourth time slot, if the station 4 has sent the data, only after that the time will, or the time slot for the station 1 will again return back. Okay, and again when it returns back, it will again only be able to send the data, right. So again as we have seen in the case of Aloha, it will not send the data as it wants, so it will have to wait for the time slots and then it will have to send the data, right. And again this is another protocol by which we can allow stations to send data in a single channel at the same time, right. But obviously they will have to follow what, the time slots that are actually given to them. Okay, and in the previous case we have seen that they are actually following the what, the frequency slots that that is actually given to them. Okay, now obviously I hope FDMA and TDMA is clear to everyone, because it is very easy actually. In the case of CDMA, let us understand what happens. Okay, so first and foremost we need to understand that what is CDMA. CDMA is nothing but code division multiple access. So just remember this, it is code division multiple access. It is not carrier, right, it is not connection, it is just a code. Now this code is the actual keyword. Now we will be able to we will see that how what is the code actually, and how this code is actually working in allowing multiple stations to send data at the same time. Okay, now first and foremost, what is CDMA? The CDMA is a very popular technology, or was a very popular technology, that is actually used in mobile communications, right. So after GSM, when we had GSM, then after GSM, so data connections were very poor, right. The call connections were not of that high quality. There were frequent call drops, there were frequent call interceptions, these kind of things, and security was also not that high. And for that reason, we came up with another technology that was known as CDMA, and various operators in India as well, they use CDMA, like Reliance, like MTS, like Tata Indicom. And after the entry of 3G and 4G, and obviously these technology actually got out of the existence. Okay, so let us understand how this technology actually works. So again you can see that if we have four channels like this, so we have 1, 2, 3 and 4 channels, right. And we can see that for the first channel, the data that it is sending is actually represented by D1. Okay, for the second channel, the data that it is sending is actually represented by what, D2. Right. For the third channel it is D3, and for the fourth channel it is what, D4, right. And again we can see that for each channel there will be a code of its own, right. So each channel will have a code of its own, right. So again for the first channel we have C1, for the second channel we have C2, for the third channel we have C3, and for the fourth channel we have what, C4. Okay, so all the stations will have codes of itself, unique codes of itself. Okay, now so whenever it sends the data, suppose the station 1 needs to send the data into the common channel, so what it will do is it will just multiply its data with its code, right, and then it will send the data to the actual channel. Okay, similarly we can see that for the station 2 it will actually multiply its data D2 with what, its actual code, that is C2, and it will send it to the actual channel. Similarly for D3, for the station 3 we can see that the data was D3, code is C3, and actually we are sending what, the product of D3 and C3. And again for station 4 we can again see that we are actually sending the product of what, the data D4 and the code C4. So right, so we are sending D4 and C4, right. And whenever these multiplications of products of data and codes are actually given to the channel, so what happens is the channel will obviously, what it will do, it will just add them together and will transmit the data. Okay, so again you can see that in the common channel, whenever the data is being transmitted, it is actually in the form of what, sum of products. So it is D1 into C1 plus D2 into C2 plus D3 into C3 and plus D4 into C4. Okay. Now, so first and foremost, we need, as we have said earlier, that every channel will have a unique code of itself, right? Now, what's the code? Let us understand. So again, since we have 4 channels, what you can do is you can remember the codes, right? So that is one way of doing things, right? So for the C1, everything will be plus ones. So 4 bits, and every bit is a positive 1, right? For C2, we have 4 bits, plus 1, minus 1, plus 1, minus 1. For C3, we have plus 1, plus 1, minus 1, minus 1. And for C4, we have plus 1, minus 1, minus 1, plus 1. Okay. But again, if you don't want to remember this, so there is a way by which we can actually find out what the codes will be actually. Okay. And that concept is known as what? Nothing but Walsh table. Okay. Walsh, WALSH, that is Walsh table. So what is this Walsh table? The 2 rules that are actually given below. Okay. So if you see the first rule in the case of Walsh table, the first rule says that if we have W1, right? Just listen to this carefully. So if we have W1, it will be a matrix of only one element, and that will be what? Plus 1. Okay. And what's the second rule? The second rule is if it is W2n, right? So if the first one is W, here it is written W1, but actually it will be W1n. So if it is 1n, if it's a matrix of a single element, and that element will be a plus 1. And if it's W2n, then what will happen? It will be a matrix of W1n's. Okay, it will be a matrix of W1n's. Okay, and what will be the order? It will be W1 plus W1n plus W1n plus W1n and minus of, or the inverse or the transpose of, or the complement of W1n. Okay, am I clear till this? So let me repeat myself once again, just a second. So again you can see if W1, if I say this is W1n actually, so if W1n is plus 1, what will be W2n? It will be, so it will be W1n, positive of W1n, positive of W1n, positive of W1n, right? And the complement of W1n. Okay. So what will be the values? Let us see. So again, if we are seeing that W1 is equal to plus 1, right? So W2n or W2 in this case will be equal to what? Positive W1n, positive W1n, positive W1n, and negative or complement of W1n. So what is W1n in this case? It is plus 1, so it is plus 1, right? So it is plus 1, so that is positive of W1n. It is plus 1, so it is positive of W1n. It is plus 1, so it is positive of W1n. And again it is minus 1. Why? Because we are actually doing the complement of W1n. So W1n is plus 1. What's the complement of it? It is minus 1. Okay, so this is for W2, right? Now we have 1, 2, 4, 8 and so on. So how do we select that number? We select that number because in this case we have actually 4 channels, right? So we need 4 codes. So obviously we need 4 codes, so obviously we need W4. Okay, and if W2 is this, can you tell me what is W4? So W4 obviously will be equal to what? It will be a matrix. And what will be the matrix? It will be W2n. Just excuse my handwriting. It will be W2n. It will be W2n. Right? It will be W2n. And it will be W2n. And that will be what? A transpose. Right? And in this, if I just look at this, so obviously W2n is what? Plus 1, plus 1, plus 1, minus 1. So again you can see that we are actually having what? The positive W2n here. Okay. Again we are seeing that we are having what? A positive W2n here as well. Right. Again we are seeing that we are having a positive W2n here as well. Right. And again for W2n in W2n the complement, what we are seeing, so we are just taking W2n and we are converting every positive into negative and every negative into positive. Okay, am I clear till this? Yes, no?
Yes, sir.
Okay. So now, how do we find out the codes? Okay. So for the first channel, the code will be what? The first line of the matrix. Okay. For the second channel, the code will be what? The second line of the matrix. Okay. For the third channel, the code will be what? The third line of the matrix, third row. And for the fourth, it will be the fourth row of the matrix. Okay. So again, if you just check for for the first channel, it will be +1 +1 +1 +1. So just check with this. Sorry, just check with this. What is happening? Just a second. Okay, so just check with this. Okay, anyways, I forgot. I forgot how to do the. Yes, this is the way. Okay. So again, let us check for C1. We have actually what? +1 +1 +1 and +1. Okay. For C2, for the code 2, we actually have what? +1 +1 +1 and -1. So again, we can see the same thing. Okay. For C3 again, we have what? +1 +1 -1 and -1. So again, we can see the same thing, right? And again for C4, what we are having? We are having what? +1 -1 -1 and +1. So again, we can see the same thing that is happening here as well. Okay. So now since we have got the codes, let us understand how the scheme actually works. Okay. So if I have data, so data is represented using this scheme. Okay. So if the data is a 0, so it will be a -1. If the data is a 1, it will be a +1. And if the station is not sending any data, so it will be what? Silent state. So silent state actually will be what? A 0. Okay. Now, so using this scheme, let us see what happens actually. So again, so suppose what is happening is the station 1 is actually sending what? A 0 bit, right? So obviously, what is a 0 bit? If you remember, the 0 bit is nothing but the -1. Okay. So if we are sending a -1, so if the data is a -1, we are having the code for the channel 1, that is +1 +1 +1 and +1. Okay. So what we will do, we will just multiply the data with the code. So if I multiply -1 with everything, it will all become what? -1s. Okay. So that will be the data that the station 1 will actually send to the common channel. Okay. Again for C2, if it is sending a 0, it is actually a -1. And what's the code? +1 -1 +1 and -1. So again, if I just multiply this, it will be what? -1 +1 -1 and +1. Okay. So this will be the data that station 2 will actually send to the common channel, right? Similarly for station 3, we can see that it's a silent. So since it's silent, it is actually what? A 0. And we will multiply everything with a 0. So everything will become a 0, right? And again for C4 or station 4, we're actually sending what? The data bit 1. So obviously 1 is what? +1. Okay. So if I just multiply +1 with the code, that is plus minus minus and plus, so obviously it will remain the same. It will become what? +1 -1 -1 and +1, and this data will be actually sent to the common channel, right? Now whenever these datas will actually go to the common channel, we have seen that we are actually having the sum of these data. Okay. Now let us see the next example. Okay, just tell me whether this is the sum or not. So just check by yourself. If I just add -1 -1 -1 -1 -1 +1 -1 +1 0 0 0 0 and +1 -1 -1 and +1, just see if I add these. So just see if this is the data or not. Just quickly check and tell me.
Yes, sir.
Yes.
It is.
Yes, sir.
Okay.
It's addition.
Okay. Okay. Now let us see what happens next. Now we can say that if the data capital D on the channel is D1 into C1 plus D2 into C2 plus D3 into C3 plus D4 into C4, if I consider this as the capital D, then the receiver which wants to get the data sent by station 1, okay, so suppose there is a receiver who wants the data only from station 1, but it actually has what? The summation of all the data, right? So if it has wants the data from station 1, what it will do is it will just multiply the whole thing with the code of station 1. Okay. Now if the code of station 1 is C1, so what I will do, I will actually multiply the capital D, that is the whole data, with C1. Now if I just break this up, you can see that it is what? the actual data, that is d1 into c1 plus d2 into c2 plus d3 into c3 plus d4 into c4, and we are actually multiplying this with a c1. Okay. Now again, if you just calculate, which means if the code is plus 1 plus 1 plus 1 and plus 1, if I just multiply this with plus 1 plus 1 plus 1 and plus 1, it will be the same thing, that is plus 1 plus 1 plus 1 and plus 1. Okay. But if I multiply plus 1 plus 1 plus 1 plus 1 with any other code, right, the result will be all zeros. So you can check that as well. Okay. So if I multiply c1 with a c1, the result will be what? If I just do the addition, it will be plus 4, right? Because if I multiply this with the same thing, it will be plus 1 plus 1 plus 1 and plus 1, and if I just add them, it will be plus 4, right? But similarly, if I just multiply c1 with c2, the result will be all zeros. If I multiply c1 with c3, result will be all zeros, and if I multiply c1 with c4, result will be all zeros. So you can also check this as well. Okay. Now let us look at what happens. So again, the same thing is here as well. So which means we are multiplying c1 with everything. So you can see d1 into c1 into c1. Similarly, d2 into c2 into c1, d3 into c3 into c1, and d4 into c4 into c1. Okay. Now obviously, if we are multiplying c2 into c1, as I said earlier, it will be a 0. So it will be d2 into 0. Again, d3, c4 into c1 is 0. So d3 into 0. And again, for c4 into c1, it is 0. So d4 into all this will be zeros, right? And obviously, if all these are zeros, we are actually left with what? d1 into n. Now what is n here? N is the number of stations. That is actually 4. So it will be 4 d1. Okay. So you can check that as well. You just multiply the codes with by itself, it will be 4. And if you multiply the codes with the different other codes, you will be actually having a 0, right? So again, so as we have discussed the same here as well. So okay, so again we have seen that if we do just a second. Okay, so if we do c1 into c1, we will be actually having 4 of n, and if we do c1 into c2, we will be actually having 0. Okay. Now obviously, if I have 4n, if I have 4 into d1, sorry, not 4 into n, if I have 4 into d1, and if I just divide the result by the number of channels, that is 4, so we will actually get what? The d1, right? So again, let us see an example here as well. So again, if d1, if d in the previous scenario, in this case, if it is minus 1, minus 3 and plus 1, so if it is minus 1, minus 3 and plus 1, if we multiply this with c1, so what is this? Minus 1, minus 3 and plus 1, and if I multiply this with plus 1, plus 1, plus 1 and plus 1, what is this? It is actually the code of the first channel, first station. So we will actually get what? Minus 1, minus 3 and plus 1, and if I just add this all up, it will be what? Minus 5 plus 1, and it will be equal to what? Minus 4, right? And if I just divide this minus 4 by the number of stations, so the number of stations is actually what? 4, so we will get minus 1. And let us see if I get minus 1, if that is the data of the station 1 or not. So again, you can see that if I get minus 1, it is obviously what? The data of the station 1. Okay, am I clear till this?
Yes, sir.
Yes. Okay. Okay. So again, this is the way how actually CDMA actually works. So code division multiple access actually works, right? So again, with the name, you can understand what's a code and how do we divide the code, right? Finally, to get the actual result, right? Obviously, so code division means what? That every station is actually having a unique code by itself, and using these codes, we are actually dividing the channel into 4 sub channels. How do we do this? This is the method. How do we do this? Okay. So I hope it is clear to everyone. And again, if you have any questions for today's class, you kindly ask me. Also, if you have questions for the previous classes as well, that also you can ask me. Okay. If not, that will be all for today, and that will be all for my part, my part of the syllabus in computer networking. Okay. And so again, Saurav sir is left with another 1-2 classes. Wong ma'am has completed the classes. I have completed the classes today. And after the midterms, if you have any classes, we will give some assignments. What will be the assignments? It will be based on the suggestions that we will give before the exams. Okay. So again, look into those assignments very carefully. And again, you have your midterms the next week, I guess. So again, best of luck for that. Okay. if you have any questions, you can ask me. If not, you can leave and you can give the uh, okay. Urunaboy did not add you. You were in the meeting, na?
Yes.
Okay.
Where should you have added me?
Okay. Okay. Anyways. Okay. So I will stop the presenting first. Okay. So again, if you have any problems, you can stay back and ask me the questions. If not, you can leave and you can give your IMCRP exams. Okay. Thank you so much. That will be all.
Sir, you said you didn't add me. Where?